Okay, so this is a walkthrough guide for how to wire the Planet CodeBot 3D printed Beetleweight robot. As you can see, I've got my robot here. We've got our 3D printed chassis, and then all of the parts are contained within the body itself. Not in the robot at the moment is a battery. As you can see, it is a Turnigy 700 milliamp hour battery. This is a 3-cell, so it's 11.1 volts. Okay, so if I pick the robot up, just so you can see, we are using Fingertech wheel hubs. And then on the inside, you can see the plastic hubs that came with the Beetleweight drive kit. Those hubs line up and go through the plastic, which has been 3D printed. It took a few attempts to get those holes to line up perfectly, but the current version of the file works pretty well. Now, if we look at the wiring itself, it breaks down into several parts. Just remove that screw. None of this has been tightened or had Loctite applied for it, because this is a work in progress project. So we have our two motors here. These are what power or move the wheels. Each one of these motors has been soldered to one of these. This is a brushed ESC, or an electric speed controller. This essentially takes the input from the transmitter, and it tells the motors to move forwards or backwards and what speed they should be doing. So we have got two of these, and I will separate them so we can see them a bit more clearly. Now, these have been soldered to the metal pads as such, and then those have been soldered to the motors themselves. I've got some heat shrink on this one to cover up the connections. I haven't done that on this side, and before I would use this robot properly, I would use that to make sure that my connections are nice and tight. Now, my speed controllers then have two sections. They branch off. We have got the black and white cables here, which connect to the transmitter. That is a simple case of lifting it up and then plugging it back in. There are two of those, one for each one of the speed controllers. Then each one of my speed controllers also has a black and a red wire. This will lead off to help form the rest of the circuit and to create the power. So the red wire runs from the speed controller, and it is currently connected just using one of these little twist pins. Again, you wouldn't use this if you were going to compete, because it would fall apart. However, for testing, they work really, really well. It also means you don't have to solder, which is always an advantage in my eyes. So this red wire here from the one speed controller is running in. We also have the second red wire from the speed controller running into the other end. Also connected to this red hub is the red wire coming from my battery connector, and then the red wire from my BEC. This is the battery elimination circuit, which just helps not blow up the transmitter, because it can't take the full voltage of the battery. I then have a second hub. This is connected again to the two speed controllers. One going here, the other here. We've got the black wire from the battery eliminator circuit, and then we also have the black wire for the battery connector. The connector I had to match up. Now, I didn't have one of these when I first bought the battery. I had XT60s rather than 30s, so I had to buy a connector and then solder these together. So the wires have been soldered to this, and then I used a large piece of heat shrink just to kind of keep it all in place. So when we plug that in, the robot connects. You can hear those beeping sounds, which show that it is started, and it is currently waiting for the transmitter to turn on. We also have an LED, which is a safety LED to show the power is running.